Okay, so last week we talked about the types of waves and we talked a lot about mechanical waves. This unit is all going to be about mechanical waves. And more importantly, sound waves. So sound is a mechanical wave because it requires a medium. That medium is air. So we can say that sound is caused by the vibration of air molecules, which causes the expansion and compression of air, i.e., changes the air pressure. So the few characteristics of sound waves: pitch is the frequency of the sound wave. So high pitch is caused by high frequency of sound. Low pitch is caused by low frequency of sound. And the intensity is the volume of the sound measured in decibels, determined by the amplitude of the sound wave. So a higher amplitude equals a higher volume. Remember that the amplitude is the height of the wave. So a higher height of a sound wave, the higher volume is going to be. So once again, high pitch is caused by a high frequency of the sound wave, and low pitch is caused by a low frequency of a sound wave. So how is sound made? Well, sound is made by the refraction and compression of air molecules. So rarefaction is the expansion of air molecules, meaning they move farther apart, so it's lower pressure. Compression is the compression of air molecules. They move closer together. So the molecules move back and forth, and that's how they vibrate. They go farther out and then closer together. So here, for example, these areas of clusters here, where there's a lot of air molecules, that is compression. They're closer together. And for example, here I'll also just use a line. This area here, this is the rarefaction. The molecules are moving farther apart. So we'll label this C for compression. All the points are compression. And then we'll label this R for all the points of rarefaction, points where the molecules spread out. So the sound wave can be measured by atmospheric pressure. So where there's a crest or a peak, we talked about this. The crest is the top of the wave. That is compression. And then when at the bottom of the wave, here, you have bottom of the wave here. Oops. At the bottom of the wave, you have rarefaction. So before we talk about wave behavior, we talked about frequency and sound. So how does our voices make sound? Well, inside your throat, you have vocal cords, muscles that fold in and out, and it vibrates the air inside your throat, and then it comes out, and it vibrates the air outside. And we talk about frequency. So the voices tend to vibrate at a lower frequency, which is why men have a lower pitched voice. Women, on the other hand, tend to have a higher frequency, but maybe about 200 hertz, and that causes women to have a higher pitched voice. And children, when you're very young, children have very, very high pitched voices. They vibrate at about 300 hertz, and it slows down as you get older. And they have even higher pitch because the frequency of the vibration of the vocal cords is higher. Alright, so let's talk a little bit about wave behavior. So waves can do different things. So for example, a wave can come up and collide with something and bounce back off. So for example, this wave here is coming in and it is it might be traveling in, and then it bounces back. It comes back. That's reflection. It reflects off the object. Absorption is when some or all the energy is lost inside the object after collision resulting in smaller waves. So either all the energy goes in and it doesn't come out, or the wave comes out smaller, which means it lost energy. So absorption is when it absorbs some of the energy inside the object from the wave. Transmission is when the wave passes through an object. So it just goes right through it. Some of it might be lost. It might have a mixture of absorption and transmission, but there's some of it that makes it through, and that is transmission. So transmission is when the wave passes through the other side of the object. So waves actually, part of the behavior we study of waves is interference. So interference occurs when two waves meet. So constructive interference occurs when two waves in phase meet with the crest of the first wave meets a crest of the second wave, and they combine to make one wave with a bigger amplitude, so a bigger wave. Deconstructive interference occurs when two waves out of phase, meaning that a trough and a crest meet. So the first wave meets with the trough of the first wave meets with the crest of the second wave. So I'm going to do an example of this on the next slide to combine to produce a smaller wave or destroy the wave completely. So what I mean is this. So constructive interference, there has to be, for example, you have, oh, that's not what I want. You gotta have the crests of two waves meet and see how it adds up to make a bigger wave. Deconstructive interference occurs when a crest meets a trough. In this case, it's perfectly deconstructive because it's perfectly in phase and the trough lines up with the crest perfectly, so it's destructive, the wave gets destroyed. So constructive is when two crests or two troughs meet. Deconstructive is when a trough and a crest meet. Wait, so sound wave interference. Beats occur when two sound waves with different frequencies interfere with each other. So there's a mixture of constructive and deconstructive interference. So when you get a beat, you have two or more sound waves interfering with each other. So you have alternating loudness and softness, smaller and bigger amplitudes, just like we saw on the last slide. And I'm going to do the beats demo in a second. The last thing about wave behavior is the Doppler effect. The Doppler effect is the change, increase or decrease in the frequency of a wave as the source, the object producing the sound wave, moves towards away from the observer, the person listening to the sound. So how that works is, for example, this. When, for example, if you ever heard of an ambulance go by, as they come towards you, you hear a louder, a higher pitch sound, but as it moves away, it gets lower. That's because these waves at the front of the ambulance, here, they're being compressed by the object. So when the waves are getting closer and closer together, you have a higher frequency because there's more waves passing towards you per second. In the back, the waves get farther and farther apart because the sound is moving. And so as the waves get farther and farther apart, you're going to experience less waves per second. It's going to take longer for each wave to hit you, thus a lower frequency, thus a lower pitch. So I'm going to post videos on beats and the Doppler effect. And then we're going to do some example problems as well.